afternoon. This is David Wallace with PV Reporter, and we are reporting live from ASH 2016 in sunny San Diego. And I'm here today with Dr. Raajit Rampal from Memorial Sloan Kettering in New York City. Nice to meet you, Dr. Rampal.
Pleasure to be here.
I wonder if you could just give me a little bit more about your background.
So certainly, I did my medical training at medical school at Stony Brook University, did medical training at the University of Chicago for internal medicine, and then Memorial Sloan Kettering, where I did my hematology and oncology clinical training, as well as laboratory training under the mentorship of Ross Levine, and I've stayed on at Memorial.
Okay, all right, very good. What I wanted to talk about today was one of your several studies that you were involved in, the synergistic therapeutic efficacy of the combined JAK1 and 2 pan-PIM CD4/6 inhibition in MPNs. That's a mouthful. So what I'd like to do is ask you, first of all, to kind of break things down in layman's terms, try not to be too technical, but if you can give me kind of the overview of the trial and what the results were, and just let's dive right in.
Certainly. So, we know without question that Jakafi or ruxolitinib has had a profound effect for patients in both myelofibrosis but also in polycythemia vera. But we also know that it doesn't necessarily cure the disease, and we also know that over a period of time, a subset of patients will lose their response to therapy. And so what we need to do is to build on the success of ruxolitinib by adding other agents that might work with it. And that's really the, I think, universal concept for how we approach this study. Now, one of the ways that we can do that is to think about the JAK2 gene. The JAK2 gene, when it gets mutated and activated, it turns on a lot of other genes and pathways within a cell. One of the ways that one of the pathways it activates is what we call the cell cycle. So the cell cycle is really what allows cells to divide. It results in replication of the DNA of the cell so that it can divide in two and continue to grow, or to also just for normal cell homeostasis for it to cycle, because if it doesn't, it can go into a state where it will eventually die.
Okay.
One of the things that has been found is that these pathways all seem to turn on the cell cycle and make it more active. And we think that might be contributing to why these cells grow, there is myeloproliferation.
Mm-hmm.
So there are a lot of different, I guess what we might say, switches within the cell that would allow us to maybe turn that off or to turn that down. Okay. And two of the drugs that we have here, one of them is called a CDK4/6 inhibitor, that is a cyclin-dependent kinase 4/6 inhibitor.
Okay.
And the other drug is something called a PIM kinase inhibitor. PIM is another one of these switches. These are targetable things, and so the idea was that if we can use these two drugs with the Jakafi, maybe we could slow down the growth of the MPN in our mouse models.
Okay. So it looks like the results at the survival, was I reading it correctly that it was 100%?
Yeah, so really quite strikingly, what we did, or how we did the experiment, was that we did it a couple of different ways. There are mice which can develop myelofibrosis.
Right.
And when you give them Jakafi, their spleens shrink, and they live longer than if you don't give them anything,
okay,
which is very similar to what we see in people. Interestingly, though, over time, they, like people, will lose response, and they do eventually end up dying, even though they're treated with ruxolitinib. What we found in the first experiment was that if you treat the mice with the triple combination of drugs versus if you treat them just with the ruxolitinib, they survive quite a long time. And when we ended the experiment, all of the mice that were treated with the triple combination were alive at about 150 days, but all of the mice that were not treated or were just treated with the Jakafi had succumbed to their disease. And we think that's a very interesting finding.
Okay.
And when we looked inside the mice, all of their spleens had shrunken, the livers had shrunken, and their blood counts were very well controlled. And to us, that was a very interesting finding.
Okay, that's impressive. Anytime you're able to achieve 100% on any trial, that's a plus.
Mm-hmm.
Were there any pitfalls along the way? Anything that didn't go as planned, or tell me a little bit about that.
Sure. The thing that we always have to worry about when we do these types of experiments, or if we do clinical trials, is that we could get a lot of toxicity if we keep adding more drugs.
Mm-hmm.
But what was really interesting to us is that if we look at mice who got the 3 drugs as compared to the ones that just got the Jakafi, their other blood counts remained stable. Their red blood cells count remained stable, their platelet count remained stable, so there was no toxicity in terms of their blood counts.
Okay.
It's not always easy to tell toxicity in mice. You can't ask the mice how they feel,
Right.
but you can see how they behave and if they survive, and from that standpoint, the mice did very well.
Okay. So, as a summary of the trial, what would you say were the greatest benefits that you saw at the end?
Mm-hmm. So I think, fundamentally that the mice survived longer than they did if they were just treated with the ruxolitinib, and that their organs were shrunk as compared to either ruxolitinib or to not being treated at all, and that finally their blood counts were well maintained and remained stable for this entire duration of the experiment.
Okay, and I guess the next logical question that comes to me is, where do you see this going as far as perhaps a phase 2?
So that's a great question, and the answer to that is that this is actually being run as a phase 1 trial in Europe right now.
Okay.
So it is open, and I think we really don't have any results to date, so I don't know any of the data pertaining to that, but that is an open and ongoing trial, with the same concept in people with these diseases in Europe right now, and I hope that we'll have some results to see in the not too distant future.
Great. Okay. I'm excited about anytime there's a combo involved, because I've been on various therapies myself, and single agent interferon had a problem with. Once we tacked in another drug, kind of smoothed things out. My counts became better, less side effects, and so I'm excited to hear more on that. In summation, let me ask you, what do you see as some of the highlights from ASH 2016 this year?
Mm-hmm. I think that there are 2 important trials that are going to be reported. Well, there are a number of important trials. As it pertains to both PV and ET patients, there are 2 trials. One is the MPD-RC112 trial, which took patients with PV or ET who were untreated and randomized them to hydroxyurea or to interferon therapy. And as you know, these are 2 of the major drugs that we use in these diseases. And so that's going to give us a first look as to whether are there differences and how patients do with those drugs. Are there differences in their outcomes? This is an interim analysis, and so this is not the final analysis of the trial, but it will at least give us a hint of that. A trial that is very similar is something called the PROUD-PV trial,
Yes.
and that will also be reported tomorrow. Both of these will be reported at the sessions tomorrow, and so we will have, I think, a better hint about the roles of hydrea and interferon, which, again, this has been an ongoing question for many, many years in the field. Other trials that I think are interesting, there is a trial that we are also presenting for patients who have accelerated phase disease or blast phase disease. We know that a proportion of patients with myelofibrosis, as well as with PV or ET, will progress into a blast phase disease or an accelerated phase of their disease, which ultimately will become leukemia.
Okay.
And that has been historically a very difficult problem for us to treat. One of the things we've observed is that the drugs that we use to treat leukemia in patients who don't have an MPN, who just have what we call de novo AML, those drugs don't work very well for patients who have an MPN that gave rise to a leukemia.
Okay.
And so patients with an MPN who have accelerated or disease or leukemia, they behave differently, and
Right.
we have to think about these patients very differently. So one of the things that we decided to do was to do a trial using a Jakafi, which we know has some degree of efficacy in patients with these diseases,
Sure.
as well as a drug that is called decitabine, which
Okay.
is an anti-leukemia drug. It's also used for a disease called myelodysplastic syndrome, and sometimes it's used for leukemias. We combined the drugs in a phase 1 trial to see if it was safe to administer the drugs together. And we found that, in fact, it was. We actually went up to 50 milligrams twice daily of ruxolitinib, which is higher than what is typically
Sure.
given.
Mhm.
And so we really didn't see any overt toxicities from that combination. And we saw some good responses, but in a phase 1 trial, it's hard to know what responses mean. So we're now going to move that on to a phase 2 trial, which is already enrolling. And this is the MPDRC 109 trial.
Okay.
And so hopefully once we have the phase 2 results, we'll have a little bit more information. But at least the phase 1 data was sufficient to allow us to move on to the phase 2 trial.
Okay. All right, very good. And if I recall, you're speaking later on some of these trials?
Correct. We'll be speaking tomorrow about the 109 trial.
Okay, very good. Well, this has been David Wallace with Dr. Rampal reporting from ASH 2016 in San Diego, and it was a pleasure meeting you.
David, a pleasure, of course.
All right, thank you.